Hi friends, here we have a function defined from 1 to infinity to 1 to infinity, close brackets. What is f of x? 2 power x into x minus 1. Then what is f inverse x? How do we calculate f inverse x? We equate this to some y and we express x in terms of y. Okay, so that is how we calculate f inverse. Let's see how we can do this. 2 power x into x minus 1. 2 power x into x minus 1 should be equal to y. Let us take log 2 on both sides. Let us take logarithm on both sides. Then x into x minus 1 will become log y to the base 2. That means x square minus x minus log y to the base 2 is equal to 0. So this is in the form of a quadratic equation, ax square plus bx plus c. Right. So what are the roots? Minus b, that is 1, plus or minus b square, that is 1 minus 4ac, that is minus of minus, which is plus 4 log y to the base 2 by 2a by 2. Okay, so basically we have 1 plus 100, 1 plus 4 log y to the base 2 and 1 minus this thing. We have 1 plus this thing, or half plus this by half, and 1 minus something. Okay, by 2. Okay, now which one to take? Which one to take? So now here, if you see, f maps from 1 to infinity to 1 to infinity. What does that mean? F inverse also should map from the domain will be 1 to infinity to the range also to be 1 to infinity. Now, if you see, let us take both the cases 1 plus something, 1 minus something. When y becomes very large, here, when we talk about inverse, we'll call this x only, right? Or x or y doesn't matter. When x becomes too large, then 4 log x will keep becoming big. The square root will keep becoming big. 1 plus a big number by 2. That will be greater than 1, or it will keep increasing, right? But on the other hand, 1 minus this when x is very big, then this 4 log x by x to the base 2, this will keep big. So 1 minus some big number, let's say some 100 by 2. This is a negative number. So if we take minus, then this is leading to negative. Okay. On the other hand, if you take plus, this is always plus. As long as x is positive, this is always plus. It will always be a positive one. If you take plus, it will always give a positive number. Whereas if you take minus, this can give a negative number. But negative number is not even possible because we can't accept anything lesser than 1. The range of this f inverse should be 1 to infinity. So clearly, this negative is taken out. Okay. So only the positive is actually left. Okay. So 1 plus and half into 1 plus 4 log x to the base 2 is the correct answer. Now, before that, we are given one more option, not defined. Whether we have an inverse or not. Firstly, we have to do that also. So when we have an inverse, when this function is 1, 1, that is this function is either continuously increasing or decreasing, then only we have an inverse. Right? Otherwise, we will not have an inverse. Right, guys? Yeah. If it is not continuously increasing, if it is decreasing, if it is increasing for some point and decreasing at some point, then what does that mean? Two x's will have the same y. And in inverse, one x has two y's, which is not possible. So for an inverse to exist, the original function should be 1 to 1. That means it is either continuously increasing or continuously decreasing. So this function is actually 2 power x square minus x. What is x square minus x? And this function is defined from 1 to infinity. Okay, x square minus x is a parabola. X square minus x parabola is a parabola. That is this green parabola, right? And here the function is from 1 to infinity. That means 1 to infinity. X square minus x has two roots. One is 0, x into x minus 1, the other is 1. So 1 to infinity means this part of the parabola, not the left part. So the right part, which is after 1, this part, whatever I am coloring it black, right? Only this part. So this part is obviously, it is continuously increasing only. Okay. It is positive and it is continuously increasing. And then what does that mean? 2 power some k or something, right? 2 power x square minus x is 2 power some k. this k is continuously increasing. Obviously, then 2 power k, as long as k is increasing, 2 power k will also increase. So, for example, when x is 0, 2 power 0 is 1. Okay, 2 power k, when x is 1, sorry, x is 1, x into x minus 1 is 0, so 2 power 0 is 1. Okay, when x is 2, 2 into 2 minus 1, right? This is 2. So 2 square is 4. When x equal to 2, 2 square, this is 4. Okay. Similarly, likewise, 3 is 3 into 3 minus 1, 3 into 2, 6, 2 power 6, something like this. Okay. So this is a graph of 2 power x into x minus 1. This is also continuously increasing. Obviously, because this is continuously increasing, because this is 1 to 1, it has an inverse. So now we are clear it has an inverse. Otherwise, we are not sure whether it has an inverse or not. Because the condition states it is between 1 to infinity. If the condition says it is between 0 to the domain is greater than 0 or greater than minus 2 or so, then this function, uh, then this is the power, the thing in the power is not continuously increasing, right? Then this need not be continuously increasing. So we have to ensure that the given function is continuously increasing or decreasing. Otherwise, what will happen if we try to do an inverse of some function, which is probably something like this. Like if we try to do an inverse of this, what does that mean? This point and this point, for the same x, for the same y, we have two different x's. This is x1, this is x2. X1 and x2 are referring to the same y. This is not one function. Right, this is not one function because two different x's are referring to the same y. And if we try to do an inverse, we will get something like this. You will get a graph something like this, which means for the same x, there are two y's, y1 and y2, which is not possible as per the definition. Right, one x can give only one y. Two different x's can give same y, but one x can give only one y. So that's why. And why is this happening? Because it is increasing and decreasing. We are able to draw a line which is actually this horizontal line, which meets at two different points, which meets the graph at two different points. If it is completely increasing, whatever line that you draw, it will always meet at only one point. If it is completely decreasing also, it will always meet at only one point. But on the other hand, if there was a small blip like this, then you can always draw a line which can meet at two different points. Right? You can always draw a line. That means at two different x1 and x2, there will be same y. That means the function is not one to one. Okay, if it is not one to one, it is not increasing or decreasing, then we cannot have an inverse. So here in this case, we have an inverse. Here in this case, we have an inverse because it is one to one, and this is the correct inverse. Okay, correct inverse because uh, only one plus we can take, because otherwise if we take one minus of this thing, then the result is negative. Result negative is not in our range. Okay, very simple problem. Just basic understanding of inverse functions is required. Basic understanding of how one function, how inverse function behaves. Right. Another very easy problem here. We have 3x minus 1. We have to find what is f inverse. Very basic. 3x minus 5 equal to y. That means x equal to y plus 5 by 3. What is f inverse? X plus y 5 by 3. And it is obviously it is 1 1 because the graph of this function, it's a straight line. Straight line is always increasing or always decreasing. Right. So straight line doesn't have blips like this. It is always increasing or always decreasing, any straight line. So, and straight line is always one to one. For each x, there will be only one y. Right. For each x, there will only be one y. No two x's will not have the same y. We do the horizontal test. This horizontal line will meet the straight line only at one point. Obviously, there is a slope here. It is not that the line is horizontal. There is a slope. So that's why this is 1 1. Straight line is always 1 1. Okay. The correct answer is this thing. Okay. So inverse is this is also irrelevant. Okay. F is not 1 1. if f has to be a 1 1 for inverse to happen. Right, guys? Thank you. Hope you like this. Bye bye.